Welcome to the dynamic frontier of space exploration, where every new discovery on Mars redraws the boundaries of our understanding and imagination. For nearly 60 years, Mars has been at the center of humanity's curiosity, and the recent decades have witnessed an unprecedented explosion in data collection and scientific breakthroughs. From the pioneering flyby of Mariner 4 to the continual presence of advanced orbiters and rovers, we are entering a new era of insight into the Red Planet, a world that may have once harbored rivers, lakes, and perhaps even life. So, what have the latest missions revealed about Mars? Let's journey through the 6 most groundbreaking discoveries that have formed our perspective on this enigmatic neighbor. We begin with the extraordinary achievements of NASA's Perseverance rover. Landing in the Jezero Crater, Perseverance has delivered some of the most detailed observations ever made from the Martian surface. On May 26, 2025, it captured a breathtaking panorama from the Falbrine site near the crater's rim. This mosaic, composed of 96 high-resolution images, offers a view stretching over 65 kilometers to distant hills, revealing features that were previously beyond the reach of human eyes. One of the most striking observations was a large float rock perched on a dark, crescent-shaped sand ripple. Geologists believe this boulder was transported to its current location by powerful forces, landslides, flowing water, or intense Martian winds, before the sand ripple even formed. The presence of such rocks is direct evidence of the dynamic geological processes that have shaped the Martian landscape over billions of years. Perseverance also conducted its 43rd abrasion of Martian rock at Falbrine, exposing the interior of one of the oldest terrains ever sampled by the rover, potentially predating the crater itself. The panorama reveals a stark transition from light-toned, olivine-rich rocks near the rover to more distant, ancient clay-bearing rocks. This clear boundary hints at a dramatic environmental shift in Mars's distant past, marking the transition from a wetter, warmer era to the cold, arid world we see today. But Perseverance is more than just a geologist. It is a laboratory of technological innovation. The MOXIE experiment, or Mars Oxygen In-situ Resource Utilization experiment, stands as one of the most significant milestones in planetary exploration. MOXIE successfully extracted oxygen from Mars's carbon dioxide-rich atmosphere, producing up to 12 grams of oxygen per hour, at a purity exceeding 98%, with a total yield of 122 grams over its mission. This achievement marks the first time a natural resource has been harvested on another planet for human use, paving the way for future missions that could rely on Martian oxygen to fuel rockets and support human life. Another star of the mission is Ingenuity, the first powered aircraft to fly on another planet. Ingenuity has completed multiple successful flights in Mars' thin atmosphere, demonstrating the feasibility of aerial reconnaissance and opening new possibilities for exploring inaccessible terrains and providing vital data for future rovers. Perseverance has also captured the first ever visible aurora from the Martian surface. On March 18, 2024, it recorded a brilliant green glow caused by a powerful solar eruption, interacting with Mars's weak magnetic field and thin atmosphere. This phenomenon not only reveals the Sun's dynamic influence on Mars, but also has critical implications for understanding the planet's climate processes and assessing radiation risks for future human explorers. Turning to the Curiosity rover, which has been exploring Jezero Crater since 2012, we continue to unravel the secrets of Mars's potential for life. On July 24, 2025, Curiosity photographed a small rock inside Jezero Crater with a peculiar coral-like shape. These delicate, branching structures are believed to have formed billions of years ago when water, carrying dissolved minerals, flowed through tiny cracks in the rock. As the water evaporated, it left behind hard mineral veins, later revealed by the relentless Martian winds eroding softer surrounding rock. These findings reinforce the belief that Mars once had liquid water, rivers, lakes, and perhaps even ancient oceans. Recent drilling operations by Curiosity have uncovered siderite, an iron carbonate mineral within sulfate-rich layers of Mount Sharp. This evidence, announced on April 18, 2025, is the first mineralogical confirmation of a long-standing theory. Ancient Mars was enveloped by a thick, carbon dioxide-rich atmosphere that kept the planet warm enough for liquid water to persist on its surface. This suggests Mars may have once operated a carbon cycle similar to Earth's, further bolstering the case for its habitability. The revelations continue with Curiosity's detection of complex organic molecules. On March 24, 2025, the rover identified decane, undecane, and dodecane, the largest organic molecules found on Mars to date, within the Cumberland drill sample. These compounds, which are fragments of fatty acids, are fundamental building blocks of life on Earth. Their discovery marks a crucial step in demonstrating that Martian chemistry once achieved the complexity necessary for the origins of life. It also raises the tantalizing possibility that large biosignature molecules could be preserved on Mars, protected from harsh radiation and oxidation. The third breakthrough centers on Mars' hidden water reserves. A study published on July 12, 2025, revealed that the planet's glaciers are composed of at least 80% pure ice, not just rock covered by a thin, icy veneer as previously assumed. This dramatically increases estimates of Mars's total water content and has profound implications for future human exploration, as these glaciers could serve as vital sources of water for astronauts. Seismic data from NASA's In-situ lander, analyzed in August 2024 and further refined in April 2025, suggest the presence of pockets of liquid water trapped in cracks and cavities deep beneath the Martian crust, between 5.4 and 8 kilometers below the surface. If these findings are representative of the planet as a whole, Mars may hold enough groundwater to cover its entire surface, with an ocean up to 780 meters deep. Orbital surveys have mapped over 15,000 kilometers of sinuous ridges, remnants of ancient river channels, across the Noachus Terra highlands. These inverted channels, formed when water-cemented sediments resisted erosion, stand as stone negatives of rivers that once flowed across the Martian landscape. Their widespread distribution and presence in separate basins indicate Mars experienced regular rainfall or snowfall, sustaining river networks for geologically significant periods. Altogether, these discoveries paint a vividly different picture of Mars, a planet that was once dynamic, wet, and potentially habitable. the evidence of ancient water, complex organic molecules, and accessible ice resources not only enriches our understanding of Martian history, but also lays the groundwork for future exploration and even the possibility of human settlement. In the upcoming chapters, we will delve deeper into how Mars's atmosphere has evolved, the mysteries surrounding the search for life, and the ambitious plans of international space agencies to bring Martian samples back to Earth and prepare for human missions. Stay tuned as we continue to journey through the unfolding story of Mars, one discovery at a time.